It's crazy how many people message me because they want to start building RAG applications. So this is what I decided to do. I created the simplest RAG system that you could ever imagine. Only a few components, only the very fundamental components for a system to work. And my goal is to break down, in this video, break down every one of those components into why they're here, how they work, why do you need them, so anyone who knows a little bit of Python can watch this video and leave with a full understanding of the fundamentals of RAG applications. That's the only prerequisite for you to watch this video. You must know Python. Other than that, you're gonna be able to follow along and understand a bunch of stuff that people don't tell you normally because everyone jumps into the code too quickly, in my opinion. There are a bunch of bonus here. So number one, I'm gonna be using Llama 3.1, which is an open source model. So you don't have to worry about OpenAI or paying them money or getting an API key, none of that nonsense. We're gonna be using Llama 3.1, which is gonna be running locally, which is a big, big plus. Everyone knows open source. There is, however, one downside of using Llama 3.1. If you only have a CPU in your computer, this is not gonna be fun because it's gonna be slow, okay? If you have a GPU, you're golden. If you don't, CPU, a model running locally, not a good mix. So here is what I'm doing for those of you who don't have a GPU. I'm gonna be using Lightning Studio. Now, Lightning is sponsoring my video here, but I want just to take a second to show you what Studio will do for you because it's super, super cool. So first of all, here is their webpage. I want you to go there, take a look at all of the features that they speak about here. But what I want you to understand is that Lightning is like having Visual Studio Code in a browser. That's my quick summary. And I know they're gonna kill me because it's way more than that, but my quick summary is Visual Studio Code in the browser. But all of a sudden, we have access to GPUs. A lot of GPUs. So we can go as crazy as we want just by clicking a button and switching environments. And that's another big, big, big thing of Lightning. I can be doing all of my work on a CPU, and I click a button, and now I have a GPU, and my entire environment is gonna be ready for me. I don't have to reconfigure everything, which is huge. So just take a few seconds, go to their page. You're gonna see all of the features, and anyway, you're gonna see me using Studio right here. Let me switch to that tab. This is the notebook that I built, and as you can see, a bunch of diagrams. We're gonna go through all of them step by step. You're gonna find the code. Number one, if you open the Studio on your browser, you're gonna get all of this code, obviously. And number two, there's also gonna be a link with a GitHub repo that you can clone on your computer and just go at it there. So this is the simple application that I built, okay? I decided to just build a system that can answer questions from a PDF. Now I want to be very, very clear. Most of what I just built here, you can just do by just uploading the PDF document to ChatGPT and I'm asking questions about the document. The document is not even that long. I still decided to do it this way just to keep things simple, okay? You can extrapolate what I did here to a whole folder of PDF documents, many, many more documents that would not fit on ChatGPT's context window, okay? So I went to Paul Graham's website and I grabbed two things that don't scale, this essay here, and I exported it as a PDF. And that is this file here, paul.pdf. That is the file that I'm going to use to break down, save it in a vector store database. We're gonna talk about that in just a second, and use the model to answer questions from that essay. So it's gonna show you how to expand the model's knowledge with a PDF document that the model doesn't necessarily know about, okay? So here is a variable. I'm just starting out here with a variable that points to the document. It's paul.pdf, as you can see here. Okay, very simple. And the model that I'm going to be using is 3.1, Llama 3.1. Now, how do we use a model? Let's start by configuring that. How do we use Llama 3.1 on our local computer? So I'm gonna open a terminal window here. And in my terminal window, I'm going to be running, if you go to the readme.md file, you're gonna see the commands that you should run in order to configure your environment. So I'm gonna start by just upgrading PIP, which is the package manager that help us here with Python. And then I'm gonna be installing the requirements. And here in the requirements.txt file, if you open that file, you'll see all of the libraries that I'm using. Actually, I'm not using Streamlit, so I can get rid of that. You don't need that. Here you can see all of the libraries that you're gonna need to install in your environment in order to run my notebook, okay? So very, very simple. I'm gonna close that now. Next, we need to install Llama. So let me open here a browser with Llama. Llama is what's gonna allow us to run a model locally. So this is an application you're gonna have to install. Now here, I'm running inside Studio, so that is a Linux environment. So if I click download here, you're gonna see that you're gonna get information on how to install it on macOS, Linux, or Windows. I'm gonna go to Linux because that's what I'm using. I'm gonna copy that command and I'm gonna run it here in my, not there. I'm gonna run it in my terminal window. So you can see it's just installing Llama and that is ready to go. Notice something very important. It says NVIDIA GPU installed. And that is because I'm running right now my Studio with a 1 T4 GPU, okay? So I can switch to CPU or I can select another GPU by going here through this configuration. I'm just using a T4 GPU because that's plenty, but that's the smallest one. That's plenty for what we need to do here. All right, so now we have Llama. Now we just need to make sure we download 3.1. I'm gonna do Llama, run Llama 3.1. When I do that, it's gonna download the Llama 3.1 model, and it's gonna just present me with an interface just to try that model because I'm using the run command. If I were using like the pull command, it will just download the model. So as soon as this model is down, we can just try it out. And that is gonna be running locally within that studio, right? That studio instance. If you're running this from your computer, the Llama instance is gonna be running Llama 3.1 on your computer, on your GPU, or your CPU if you don't have a GPU, which is gonna be really slow. So let's do tell me a joke. That's usually my go-to phrase. And here is one. What do you call a fake noodle? An impasta. Oh, Jesus, this is just a bad model. All right, so let's do buy. Okay, so I have all of my libraries. I have Llama, and I have Llama 3.1 running right here locally. That's all of the setup that I need. I can just go directly to the notebook and go at it. Now, this is a Jupyter notebook. The way you run a Jupyter notebook, let me just actually close my terminal, is you go cell by cell, and you can just execute every cell. So again, PDF file is gonna be poll.pdf, and the model is gonna be Llama 3.1. Later on, we're gonna use that variable. So how is my application going to work? Well, I want the following to happen. I want to ask a question to the model about that essay, that PDF document. But obviously the model doesn't know anything about the PDF document. So I have to provide the content of the PDF document to the model. I have to tell the model, hey, answer a question using this content as your knowledge base, okay? Don't try to hallucinate something, just use this content as your model base. So think about you're building a system for a company and the company has a knowledge base. Basically that knowledge base explains how the company carries certain processes. And you want your employees to chat with the knowledge base to ask, hey, how do I finalize an invoice? What is the process to submit a request for vacation? And you want the model not to hallucinate that. You want the model to just use the knowledge base as the reference point, right? So you have to combine the question that your employee is asking this system with the knowledge base. Those two components go together to the model for the model to answer the question. But here is the problem. What happens if that knowledge base is too large? What happens if you have pages and pages and pages of PDF documents? Well, these models have a limited context window, okay? It's just a limited space of how much content you can pass them in one question. So if you have megabytes of PDF documents or gigabytes of content, you cannot just provide it all for these models, it's just too much. Instead, you need to pass only fractions of documents. Now, what is the fraction? What is the page? In this case, we have a PDF document and we want to ask a question and only give the model the pages that might be relevant to answer that question. How do we know that? Well, that's exactly what we're gonna figure out right now. So before we do anything, I'm gonna break down that PDF document into multiple pages because you and I agree at this point that no, you cannot send the entire knowledge base, okay? So I'm gonna break down the PDF document into multiple pages. That's what you get here in this diagram that I put together here. This is my wife's doing, by the way. We get the PDF document and we're gonna use a PDF loader, which is a class from one of the libraries that we installed. And that PDF loader is gonna give us back every single page of that document as a separate object. That's great, that's a good start. So let's take a look at the code here. Let me execute it first. By the way, if you have not used a notebook before, I execute every cell using Shift Enter. You can also just click this play button here and that will execute the code of that cell. So this is what I'm doing. I'm importing the PyPDF loader, which is the library that's gonna help me load the document. I'm just creating an instance of that loader, passing the name of my PDF file. Remember, that's pol.pdf. And then I'm just loading that PDF file. Now this load function already returns a number of pages, like every page as a list. So I'm gonna get a list of pages. Notice that here I'm printing out how many pages, the length of that list. And you can see we got 9 pages. And then I'm saying length of page, and I'm actually printing the length, how much content, how many characters we have in the second page. Page 1 is 0, second page is 1. It's just to have an idea how many characters fit in one of these pages. And that is 3,217 characters. And then finally, I'm just displaying the contents of this page. And that is content of the page is 10% a week, and while 110, yada, 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 you get the idea here, okay? So that was the first step. Now I have a bunch of pages, but I'm gonna go one step further. Pages still contain too much content, not because the model does not support that, bigger space, but because the more content, like if just think about you. If somebody asks you, can you answer this question using this book? There's a bunch of pages here. Yes, you can read the entire book, but it's gonna take you a long time to find the answer of that question in this book. Instead, if I tell you, can you answer the same question just using this particular page? Well, now you're gonna find that answer much quicker. Why? Because the space that you have to search for that answer is smaller. I'm gonna try to do the same thing here. Instead of just accumulating pages where an answer or a model might find an answer, I'm going to chunk out those pages. I'm gonna create smaller chunks of characters so I'm more precise. At the time of asking a question to the model, I can be more precise, and instead of telling the model, find the answer in these 3 pages, I'm gonna tell the model, find the answer in these 3 smaller chunks of information. I want to be more precise. So how do we split this? How do we do this? Well, that's exactly what this diagram shows. Notice how we load the PDF document, we get all of the pages, we have 9 pages, and then we're gonna take those pages within a splitter. Splitter is gonna take a page and it's gonna break it down following a configuration, we're gonna see the configuration right now, into multiple chunks. This is the other cool thing that the splitter is going to do for us. Not only we're gonna be chopping off a page into multiple chunks, but we're also going to do some overlapping between those chunks. Imagine this, okay? Imagine you ask a question and that the answer to that question starts at the end of a page and finishes at the beginning of the next page. That is pretty normal to happen. Actually, this section here in this book, I don't know if you can see it, but this section here does not finish there. It goes all the way to the next page. So if we're only sending the model a complete page to answer a question, we might be sending incomplete information to the model because we also need a little bit more for the next page. So how do we solve that? Well, one way that we can solve that is by adding a little bit of overlapping between the chunks. So instead of chopping off a page, let's say in 10 different chunks, we're gonna do the same thing, but we're gonna make every chunk use a little bit of the content of the previous chunk. So we're gonna go, let's say, from character 0 to character 1000, and the second chunk is not gonna start in character 1001. The second chunk is gonna start in character 800 and go all the way to 1800. And then the third chunk is gonna go all the way from 1600 to 2600. That overlap is gonna help us chain all of these chunks together in a much nicer way. So let's see how we do that. It's very easy actually. And I don't know if you've noticed, but I've been using LangChain as the library. It's like the glue that's gonna let me build this system in a much nicer, easier way than trying to do all of this by hand. So I'm using all of these pre-created classes like the PDF, like the PyPDF loader that just built out for me. I just need to use them, okay? LangChain is open source, by the way. It's just free, it's open source, so you can use it. So in this case, I'm using the recursive character text splitter. That's a mouthful. But basically what it's going to do is take my pages, split them into chunks by a number of characters, and add me some overlap, which is what I just explained. So I'm gonna be configuring here. I'm saying, hey, I want every chunk to have 1500 characters. So not the 3200 characters that are in a page. I'm gonna be chopping pages like in two, like, you know, in half approximately. And I want a chunk overlap of 100 characters. So there are gonna be 100 characters of overlap between these chunks. After I do that, after I configure my splitter, I just need to call it and split. So you can see here how I'm getting this splitter, and I'm calling the split documents function, and I'm passing the list of pages. So 9 pages come in the splitter and 32 chunks come out. So about between 3 and 4 times the number of chunks compared to pages. That is what I just created. By the way, here you can see that I can also print a chunk, and you can see just the content of the document. Now these chunks are way smaller. Awesome. This is table stakes. This is the first thing that you do. When you go to a company and you want to organize your knowledge base, you need to do something like this. You need to prepare the content that you're gonna be sending to the model together with a question. Now, there are a bunch of questions that we have not answered yet. Like now I have 32 chunks. When I ask a question, which chunks should I send to the model? We have not answered that yet. We're about to, but we're gonna get there in just a second. My point is that when you're working at a company and you want to build a RAG application, the creation of this knowledge base that's ready to be sent to a model is first a necessary step. It's one of the first necessary steps that you have to go through. Okay, so now all of these documents, all of these chunks in this case, are in this list, the list chunks. I have to store them somewhere, okay? So I can use them over and over again. The next time I come here, they're stored somewhere. So a new concept, quote unquote, that came out during this AI revolution is the concept of a vector store. So let me tell you in English what that means. That is a database that's really, really fast at storing vectors of numbers and searching for those vectors of numbers. That's pretty much in English what that means. That's what a vector store looks like. Again, it's just a database. So I can get all of those chunks, the 32 chunks that I have, and I can store them in a vector store database. But I'm not going to store them just like if the vector store was just a regular database. No. Before storing those chunks, I'm going to turn them into embeddings. I'm basically going to get like this fraction of a document, and I'm going to be generating a vector of numbers, just an array of numbers that represents that text. Now, what does that even mean? Well, I have a bunch of videos talking about, actually a bunch of videos, like 2 or 3 videos talking about embeddings, so I'm not gonna go too deep into that. But I want you to think of embeddings as like a compression mechanism that's very smart. So it can read a page. Imagine you reading one page of this book and telling me in a few words, let's say 10 words, what that page is about, okay? So if I read all of this page and summarize this page in 10 words only, I might say, well, this page is about model architecture and how to transform sentences. I don't know if those are 10 words, but imagine that I do that. And I keep doing the same thing with every page. At the end, what I'm going to get out of this book is a bunch of 10-word sentences summarized in every page. By comparing those 10-word sentences, I can easily find similar pages that talk about the same topic or maybe similar topics, right? So if page number 1 is model architecture, maybe page number 12 also talks about model architecture. And you can easily see, just by comparing 10-word sentences, you can easily see which pages are related to each other. That's sort of like the same idea behind embeddings, right? Instead of just using 10-word sentences, embeddings are using numbers, but it gives you the same benefit. With that list of numbers, I can easily determine what other chunks are similar to any given chunk. Now, the other way I like to think about embeddings is like coordinates, right? In the world, like latitude and longitude. Now, latitude and longitude, those are only 2 values, but they can represent any point in the globe, right? If I say latitude 24, longitude -33, I don't even know if that makes sense, but that will give me exactly one point in the world. And I can compare that point to any other latitude and longitude to determine whether I'm close to another point or whether I'm too far away. It's the same thing, but instead of thinking of 2 values, latitude and longitude, now think here about many numbers, many dimensions, but they just represent a coordinate in this multi-dimensional space. 2 chunks that speak about the same content, that, focused on the same ideas, are going to have coordinates in this multi-dimensional world that are very close to each other. And that is a fundamental idea here for what we need to do. You're going to see that in a second. So let's try to get this and store it in a vector store. Let's convert it to those vectors. Let's get every chunk, generate the coordinates for that chunk, and store them in a vector store. So this is the way that will look like. Here is sort of like the diagram representing that process. I'm going to get the chunks. I'm going to be using an embedding model. This embedding model is just a model that's provided by the people who built Llama 3.1 in this case. We're going to be using that embedding model, and that embedding model is going to give us back the coordinates or the vectors. We also call them embeddings, right? And these are the multicolor things. Notice that every embedding might be a little bit different. I mean, the numbers are going to be different, but we can later on compare these embeddings to determine which chunks are similar to each other. And that is a very cool thing. And then all of these embeddings, we're gonna store in that vector store database. The reason I'm using here FACE or FICE, that is a vector store that's going to store in memory. Vice was created by Meta. Again, it's just free. And that is going to keep my vector store in memory. If you were building like a real application, maybe you would want to use a different vector store database. There are multiple vector stores database out there. Pinecone is one of them. I mean, there are multiple. Postgres it has the ability to store vectors right now. So you can use whatever vector store you want. In this case, I'm just using Vice here. So let's look at the code. 2 lines, gonna do all of this. So first, I'm gonna be instantiating my embeddings model. And notice how I'm using the Llama embeddings, that's the class, but I'm passing the name of the model that I'm using, which is Llama 3.1. Every model here usually comes with their own embedding model. That's the case here. So I'm gonna be using that specific embedding model. By the way, I do not have to use the same embedding model as the model that I'm using. I can use any embedding model, but in this case, I'm just using the Llama 3.1 embedding model. So after I have that embedding model, I can use Vice, that's the class that I'm importing right here from the list of vector stores supported by LangChain. And I'm saying, hey, just create this vector store from the list of chunks that we have and use this embeddings class to generate the vectors. What's happening here behind the scenes, it's grabbing, this class is grabbing all of the chunks, is generating the vectors and is storing them in Vice. So after this line, this vector store is going to contain all of my chunks. By the way, I've forgotten to run all of these, I think. Let me run this one here. There we go. And let me now run this one here, which is gonna create all of those embeddings and store them in vector store. Notice that this is gonna take a little bit more time. I mean, it's not that slow, but this is actually going through all of the chunks, generating the embeddings and storing them in Vice. So now at this point, my vector store contains my entire knowledge base, ready to use. That is table stake again. That is very, very important, okay? So how do I get data from my vector store? How do I access those chunks, that knowledge base that's stored there? For that, we're gonna have to set up a retriever. That's the concept that LangChain uses to explain how you can get data out of the vector store. So this is the way that retriever is going to work. And pay attention because this is really, really cool. So the retriever, which I'm representing here by this dashed line, is gonna get a question. So the question, let's say the employee asks, hey, what is the process to submit an invoice? That question, we're gonna give it to the retriever. Inside the retriever, behind the scenes, that retriever is gonna use the same embedding model that was used to store the information inside the vector store database. And it's gonna turn that question into the coordinates, into the vector. Why does it do that? Because now with that vector, the retriever can find any similar chunks. The idea here is that we want to take the question, find any documents, any chunks stored in the database that are similar to that question, because that's likely where the answer is gonna be stored. So if we do this, and we retrieve any similar chunks from the vector store, the retriever can then output every similar chunk that we have in the database. See where I'm going with this? So now you ask any question whatsoever, and immediately we can give you back the chunks stored in the database that are most likely to contain the answer to that question. Very, very simple. I think you can see how easy it's going to be from here. But anyway, how do I create this retriever? Well, it's just a single line. That's the power of LangChain, that it sort of like hides all of the complexity and we don't have to deal with any of that. And that line is this one here. I'm gonna create a retriever by asking my vector store, just give me a retriever, please. And that vector store is just gonna give me this variable. And now notice how I can say, well, invoke that retriever. I'm gonna call the method invoke. And I can pass one question. What can you get away with when you only have a small number of users? And this is a question that, should be answered from that PDF. And I'm getting back 4 documents. Why 4 documents? Well, by default, the retriever is going to send back 4 chunks that are the most similar as computed by the retriever from your knowledge base. So I pass a question and you're gonna get back 4 chunks. Now I can pass whatever question and the documents might be different. Like in this case, you can see I'm getting a chunk from page 7, a chunk from page 0, another chunk from page 7, and another chunk from page 3. That's what I'm getting back. Now let me ask something different. I don't know. What did Paul say? Let me just find here fragile. Airbnb now seems, I don't know. I'm just gonna pass this paragraph here, okay? Whatever that is. I'm gonna pass that. It doesn't have to be a question, obviously, just a piece of content. I'm gonna pass that. And if I execute this, now I'm getting page 7, 0, 7, and 4, not 3 like before. I can ask something over here. I'm just gonna pass this. I'm just doing random stuff. You get the idea here. I just want that retriever to show me how I can get different things. Now it's 7704, so it's just the pages are in different order. You get the idea. I'm gonna just go back to the question that we had. Awesome, 7073. So that's the idea with the retriever. We can use that retriever, pass a question, get all of the relevant documents. So it's time to bring the model here. It's time to build like the main trunk of our solution. So far, we've only focused on putting all of the information in the cloud. Or sorry, not in the cloud, in the vector store, which in this case is running in memory, not in the cloud. It could be running in the cloud, but in this case, it's just running in my computer or in this studio, Lightning Studio instance. All of the information is there. Now, after we do that, now we can focus on the actual system using the model to answer questions. So this is the basic system. Let's start with the basics. We're gonna configure a model. So we're gonna give a question to the model and that model is gonna give us a response. That's it. This is what we want to build right now. How do we do that? Well, I'm gonna be using the chat or Llama class from LangChain, and I'm gonna be specifying Llama 3.1 as the model, temperature 0. Remember, the temperature is basically telling the model how creative it needs to be. When it's close to 0, the model will usually respond back the same way. Not really, but that's the idea. The larger the value of temperature is, the more creativity the model is going to show. So in this case, temperature 0 is fine. The model is going to be Llama 3.1. And then we can do invoke who is the president of the United States. Notice that here I'm just asking a question that is general knowledge. So the model should be able to answer that. It doesn't need a PDF document to answer that. The model should use its general knowledge to answer that. And the answer is AI message content as of my last update of April 2023, Joe Biden is the president of the United States, yada, 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 yada. Awesome, but I don't like that weird AI message format. So what's happening here is that this model invoke is returning an object, an AI message object. I want to get rid of that. I just want the answer. Please don't give me an instance. So LangChain gives us the ability to use parsers, and a parser is nothing other than a class that you can combine with other classes to modify the answer from the previous class in that chain. So I can create a chain, which is what the name LangChain comes from, with a model and a parser, and the answer from the model will be the input to the parser, and the parser will transform that answer. So just to keep this simple here, this is the first chain here. Beautiful chain, very, very simple chain. The question is gonna go to the model, but the response from the model is not what we're gonna be consuming. We're basically gonna send that response to the parser to get rid of that AI message and just give us the string. I'm gonna be using a string parser. Okay, and that's gonna be the answer, the final answer. So let's see that parser. I'm creating a string output parser. There are a bunch of parsers. You can parse out like JSON, XML, a bunch of different things. String is what we need here. That's my parser. And notice how I'm creating this chain. I'm using the pipe operator, so you can see it here. Chain, it's going to be the model, pipe, parser. That's the way LangChain allows us to create these pipelines, workflows, or chains where one component is followed by the next component. So when you see this chain and you want to interpret what's going to happen, it's very simple. The output of model will be the input of parser. And the output of parser, that's the return, okay? So now if we print out, if we call chain.invoke, who is the president of the United States, notice that the answer is the same, but now there is no AI message content equals, we just get the string. Why? Because this parser is taking that, it is extracting the text and is printing out the text. Beautiful. Let's make it a little bit more complex. So now is time to start thinking about the actual system that we're building. Remember, we're gonna be providing a question, but we're also going to be passing context. That context is the knowledge, our knowledge base, the content in this case from the PDF. It doesn't matter that it's from a PDF right now, we just know that context is stored in a vector store that we're gonna be using here. So if this is for the system for the employee to ask, hey, what is the process to submit an invoice? We want to pass the question and we want to pass the relevant chunks as the context. Now to do this, the best way of organizing this is just creating a prompt template. The prompt template is nothing else than a just very easy format that's very easy to modify, to understand, and to share with other people. In this case, this is our template. Notice that it says, you are an assistant that provides answers to questions based on a given context. That's clear. Answer the question based on the context. If you cannot answer the question, reply, I don't know. That's kind of important. I don't want my model to start making stuff up. So if it cannot answer the question using the context, the knowledge base that I'm gonna be giving it, it should say, hey, I just don't know how to answer this question. Be as concise as possible and go straight to the point. And then I have context and a variable. Variable, this is what this looks like. It's just I'm using curly braces to have context there, and the question. And I'm using curly braces for the question. This string that I just created here, I can now use with a prompt template class from LangChain. See, I'm saying, hey, just create a prompt template from this string template here, and that is our prompt. Now, that prompt, I can format it with the two variables that I just created. I can pass a context and a question. That's exactly what I'm doing here just for testing purposes. Notice that I'm saying prompt.format, and I'm gonna pass a value for context, here is some context, and a value for question, here is a question. Why context and question? Again, because these are the names that I use here. If I type here potato, well, here I'm gonna have to type, potato here. That's just the way the variables work. All right, so I'm gonna go back, I'm gonna execute this, and as you can see, this is the output, which is just the prompt already ready to use by the model. It says you're on a system, yada, 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 be as concise as possible, and go straight to the point. Context, and here is some context. Question, here is question. So think about this for a second. When this is ready, instead of context column, not instead, but after context column, we're gonna be passing the chunks, the relevant chunks to answer whatever question we pass at the end. That is what we want to do. Okay, so let's put this prompt now as part of our chain. Let's connect the prompt to our chain so we have the full picture of what this system will look like. So we're gonna get the previous chain. Let's go back. Remember, the previous chain had a model and a parser. But now instead of passing the question to the model, we're not gonna be doing that. We're gonna be adding the prompt in front of the model, because the output of the prompt, that full formatted prompt, that is exactly what we want to give the model. So we're gonna have now the prompt in front of the model, the parser after the model, and then the prompt receives two variables, receives the context and the question. That's it, okay? This system is starting to look the way it should look. All right, so let's look at the code. Again, prompt now is in front of model, which is in front of parser, and now I can invoke that chain passing context. Anna's sister is Susan. And question, who is Susan's sister? So if I execute this, There is a little bit of a problem. Oh, apparently, what happened here? Apparently, I don't have a model. Maybe I forgot to create a model somewhere. Let me just see. This is what usually happens. No, this is, I don't know what happened, but let me just re-execute everything and see why it didn't work. This is what usually happens when you're running this live. Things stop working. All right, so this is loading all of the data into my vector store, my retriever, okay? Let's create my model. I probably forgot to execute this. That's exactly what happened. I'm gonna run this now, and now I'm gonna be setting up my template, and finally I'm just gonna be executing my final chain. And again, the context here was Anna's sister is Susan, and the question is who's Susan's sister? So the model is using this information to answer Anna. That's correct. The problem that I had here was because I forgot to execute one of the cells, the cell that defines the model. I did not execute that one there. The way you usually fix it, if you know which cell you forgot to execute, just go to the cell and execute that cell. I usually prefer to execute everything from scratch, just so I don't execute any cells in the run order, because that can screw things up. So anyway, final component here, because now the context, I need to find, or I need to get the context from the vector store. That is what I need to inject this system. So how do I do this? Well, we have a retriever. We can connect that retriever as part of our chain, okay? Now let's look at this diagram before we talked about the code. Let's look at the diagram. This is the final diagram, okay? So I have the prompt, the model, and the parser, as we saw before. Now I'm connecting the retriever here. But notice this. The retriever expects the question. Remember, the retriever needs to search the vector store. Using the question, it needs to search the vector store to find the similar documents to that question. So the retriever will be expecting that question, okay? And the retriever will be outputting the context. The context is just a list of the 4 chunks that are the most similar. That's it, okay? So the context will go into the prompt, but there is also something else. That prompt also requires the question. So that is why you see the question going into the retriever, and the question also going into the prompt. So we're gonna have to do some magic there in Python for that to happen. It's not hard, but that is, we need to pass the question to both the retriever and the prompt. And because this is sequential, it's a chain, we're gonna have to do that little bit of magic. Now also notice obviously that the retriever is using the vector store. Remember, we created the retriever off of the vector store. So that's what it's gonna be using to get the information back. So here is our new chain. And again, it's not extremely more complex. So besides prompt and model and parser, now I added this component here. And this is the magic that I was telling you about of passing the question to multiple places. So notice this. So I'm gonna be invoking this chain with a question, okay? Not the context, because the context, I had to invoke the chain with context here, but now the context is coming from the retriever. So I don't need to invoke the chain with the context anymore. I'm only gonna be invoking it with a question, but I need to pass that question to multiple components. So look at this. This is a chain that is going to be getting the context to pass to the prompt from the retriever. Notice that the retriever is here. But I need to pass to that retriever, I need to pass the question. The way I do that in Python is by using the item getter function, which is basically gonna be getting that question from the input to the chain, and it's gonna be passing it to the retriever just using the pipe operator like we've seen. And the output of that I'm gonna be storing in context here. And I also get the same question from the input to the chain, and I store it here in this attribute question. And this is the dictionary that I'm gonna pass to prompt. And if we go up there, you're gonna see that that is exactly what my previous chain was expecting a dictionary with context and with question. So by just configuring it like this and using that item getter thing, I can actually accomplish this, the question going into the retriever and into the prompt. So this is my new chain. And what's really, really cool about this chain is that now I can ask questions and the context will be augmented from the content in the vector store. So here is what I created, and I suggest you make modifications to this and augment it. So I created an array of questions. I have 3 questions here just to try this out. What can you get away with when you only have a small number of users? What's the most common unscalable thing, etc., etc. And I have a for loop that goes through all of these questions, grabs the question, prints the question, and calls that chain, invokes the chain passing that particular question. Now internally, now you know what's going to happen. When I pass a question to this chain, number one, the question is going to be passed to the retriever. That retriever is going to go to the vector store and it's going to return, by going to the vector store, it's going to get back 4 different chunks from the knowledge base, in this case a PDF, that are the most similar to the question that I asked. And it's going to get all of those 4 chunks and it's going to pass those chunks to the prompt. And the question is also going to get passed to that prompt. So the prompt is just going to format the document that is going to pass, or the full prompt that is going to pass to the model. The model is going to answer that question using the knowledge that is provided right there as a context. The answer, the response from the model is going to go into a parser. It's going to get rid of anything that it doesn't need to be there. And that final text, that final answer is the one that we're going to get printed out. So let's see it working. First, let me execute this line. That works. And now I can just run this and it's going to go question after question answering that question. So here you can see, what can you get away with when you only have a small number of users? Just try to delight your users. What's the most common unscalable thing? Delighting users individually. What's the one biggest thing? They want to seem big too early, blah, blah, blah. Now, there are a bunch of modifications that you can do here. My suggestions are, number one, try with different documents. Documents that you care about. Grab a website, save it as a PDF. Try to ask questions about that PDF. Ideas will start flowing for you. Number two, play with the size of the chunks, okay? Right now I'm using 1500 characters for every chunk. I will suggest you increase that number. See how the results change as you change the configuration of the splitter. Remember, we used the splitter to generate those chunks. Here is the splitter somewhere right here. So as you change this configuration and you increase the chunk size and maybe increase the overlap, you will see how the model reacts. Number two, try to use a different model. Here I'm using an open source model. I'm using Llama 3.1. Changing this code to use ChatGPT or GPT-4 or GPT-4o or GPT-4o mini, it's very simple because most of the code stays exactly the same. You only need to change, because you're using LangChain, you only need to change, for example, here, the actual definition of the model. So if I change this line and nothing else to start using ChatGPT here, this is still gonna work, which is very, very cool. You can also change the embedding. Use different embedding classes, Cohere's embeddings or ChatGPT embeddings, and see how your results change, okay? Try to parse and store multiple PDF documents instead of one document. Try different vector store databases. I have a video that shows how you can use Pinecone, for example, as a database. Try that. That will be my recommendation for you to build upon what I just showed you here. And the more complexity you add this, the more useful these systems become. Now, as a reminder, I run all of these using a T4 GPU. You can run this on CPU. It's just gonna be very, very slow because of Llama 3.1, which I'm running using all Llama. If you were using, let's say, GPT-4 with an API key, you will not need a GPU because GPT-4 will be running on OpenAI's hardware, not on your hardware. You can come here, by the way, in Lightning Studio, and here is where you can even select a bigger GPU. if you wanted a bigger GPU for some reason. Or you can just go to a CPU if you wanted to do that. Hopefully this makes sense. If you have any questions whatsoever, try to leave those questions below in the comments, and I'm gonna try to get answers to as many of those questions as possible. Let me know what's your idea for the next video. Bye-bye.